Chemistry is often called the central science, because at its heart, chemistry is simply the study of matter. Matter is absolutely anything that has mass and takes up space. From this definition, it becomes easy to see that you really need a minimum of a baseline understanding of chemistry in order to study any science, since everything is matter. We define mass as the amount of matter that an object contains. People often confuse mass and weight, but it is important to remember that they are not the same thing. Mass is simply how much stuff is there, whereas weight is a measure of the gravitational pull on that stuff. So a person might weigh 180 pounds on Earth with a mass of 81.6 kilograms, but on the moon they would only weigh 30 pounds. However, the amount of matter that makes them up has not changed, so they still have a mass of 81.6 kilograms. We will be doing all of our chemistry on Earth this semester, though, so weight and mass are basically interchangeable for our purposes, but it is important to remember that they do measure different things. We classify matter in many different ways, but two of the most common are to classify matter by its physical state, the most common three states being the familiar solids, liquids, or gases, or we classify matter by the composition of the matter, which is what we'll discuss first. When classifying matter by its composition, we consider whether that sample of matter is a mixture of different substances or whether it is a pure substance. This chart gives us a good representation of how we classify matter according to its composition. Matter can either be a pure substance, in which it'll have a fixed composition and it can't typically be further purified, at least by physical means, or matter can be some type of mixture, in which more than one type of pure substance is present, and the composition might be varied throughout. Mixtures can be broken down into homogeneous or heterogeneous mixtures, which we'll discuss later. Likewise, pure substances can be broken down into compounds or elements. As the name implies, a mixture is a combination of two or more pure substances. There are two basic types of mixtures. In a homogeneous mixture, the composition is uniform throughout the whole thing. To the naked eye, you might not even be able to detect that it is a mixture at all. Picture something like sugar water. You wouldn't know until you drank it that there was sugar mixed in. In a heterogeneous mixture, however, the composition is not the same throughout. You will often be able to easily see that it is a mixture, but not always. This slide gives us a good representation of the different types of mixtures. In the first glass, we actually don't have a mixture at all. We have pure water, which is a pure substance with the chemical formula of H2O, making it a compound, which we will discuss later in the video. In the middle, we have lemonade made from a powdered mix. The composition of this tasty summer beverage is the same throughout the whole glass. Assuming it is thoroughly mixed, each sip is the exact same. The last glass, however, is lemonade made from freshly squeezed lemons, with pulp floating throughout. It is easy to see that the composition in this glass is not the same throughout the whole glass. Some sips might have more or less pulp than others, especially if the glass is allowed to sit for a period of time. This non-uniformity in the composition makes this a heterogeneous mixture. Oftentimes, a heterogeneous mixture can be separated by filtration, as seen here with the mixture of dirt and water. The solids can be filtered out of the water. Just as in the last slide, the lemonade with pulp, the pulp can be filtered from the rest of the lemonade. If a sample is not a mixture, then it is some type of pure substance, either an elemental substance or a compound. An element or an elemental substance is the simplest form of matter and cannot be broken down any further by simple chemical or physical means. For example, if you're fortunate enough to have a bar of pure gold, that is an elemental substance. Elemental substances consist of only one type of atom. A pure gold bar has only gold atoms in it, nothing else. The other type of pure substance is a compound. A compound is a combination of two or more elements that come together in an easily recognized manner and has a chemical formula. The most easily recognized compound is likely H2O, water. Another compound you may recognize is C6H12O6, the formula for glucose, a simple sugar. Here we see a sampling of different types of elemental substances. We have things like mercury, copper, iron, aluminum. When in doubt, if you can find it on the periodic table by itself, it is an elemental substance. At this point, there are 118 different identified elements. We will discuss the periodic table much further in Chapter 2. Compounds are still a pure substance, however they are made up of two or more atoms. Sodium chloride, for instance, with the chemical formula NaCl, is made up of the elements sodium and chlorine. When they come together in a chemical reaction, they can form sodium chloride. All compounds are made up of molecules or ions. A molecule is simply the smallest unit of a compound that still retains its chemical characteristics. Glucose, that I mentioned earlier, with the formula C6H12O6. If we have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms that come together in the configuration that make it glucose, then that will be a glucose molecule. Some elements come together in such a way that we call them binary elements. That means that if it exists by itself in nature, it exists with two of them bound together. A good example of this is oxygen. The oxygen in our atmosphere is not just made up of single oxygen atoms. However, they are made up of two oxygen atoms that are locked together. Nitrogen is another example of that. Our atmosphere is actually almost 80% nitrogen. Nitrogen is also a binary element. So all of the nitrogen in our atmosphere is composed of two nitrogen atoms that are locked together. Ionic compounds are described by what we call a formula unit, whereas molecules are described by their molecular formula. These are concepts which we will define further later in the class. Some other familiar chemical compounds here. Again, these are pure substances, but they are made up of more than one type of atom. Another way we classify matter is according to its physical state. While there are others, the most common states are the familiar solids, liquids, and gases. Any substance can exist in any state, although for some, extreme temperatures and/or pressures may be required. For example, gold will melt at a little over 1,000 degrees C. But it is also possible to boil gold and get it into a gaseous state, but that requires a temperature of 2,700 degrees C at normal atmospheric pressure. This slide shows us the element bromine in 3 different states. We will study states of matter more thoroughly later in the course, but for now, we will say that the state that a substance is in depends largely on the amount of energy the substance has relative to the forces that hold the individual molecules together. Solids have the lowest energy. As a result, they have a definite shape and a definite volume. For instance, if I take a pebble with a volume of 10 milliliters and move it from one container to the other, both the shape and the volume remain the same. Here's our pebble. We'll have 10 milliliters in one container. If we move it into a much larger container, the shape of that pebble doesn't change, nor does the volume. It is still 10 milliliters. Liquids have a bit more energy, and as a result, they will have a definite volume, but will take the shape of whatever container they are in. If I have 10 milliliters of water in a graduated cylinder, and I move that water into a beaker, the volume is still going to be 10 milliliters. However, the shape is now the shape of the new container. Our third state of matter, gases, have the most energy. As a result, they will take the shape of and fill the volume of whatever container they are in. If I have, for instance, 10 molecules of gas in this small container, each X is one gas molecule, and then I transfer those into this larger, differently shaped container, the gas molecules will fill up the new container completely. This is because gas molecules have so much energy, they are in constant fast motion, continually bouncing off each other and the sides of the container. For this reason, it is useless for us to ever discuss amounts of gas in terms of volume. We will always discuss the amount of gas in terms of its mass or its number of particles. If you have any more questions on the different ways that we classify matter, be sure to consult your textbook or see me.